So now we go to the next part, which is GANs. And in here, we're going to go through the process of making CO2 GANs and zinc GANs. Now for zinc GANs, there is another method. This is just going to be the one method. So we will be doing another method in further workshops. And I'll go through the presentation, and then during that, I'll ask Sando if he'd like to add in what he can. And then when we get to question time, then I'll hand you over to Lisa, because she makes all our GANSs here. So she's would be able to answer a lot more questions than what I could. Okay. So what is the GANS? Definition: it's a new state of matter, a molecule of a gas, which becomes nano of itself and appears as a solid state of matter. So that's where we get the short term of GANS from.
So here, maybe some people would need to understand all the words, like what does it mean, nano?
Well, hopefully they've watched the previous 4, Sando.
Okay, so just a short rehearsal, because gas we used to understand. We have gases, solids, we have liquids, such a states of matter. And what does it mean, nano? Nano comes from nanometers, which is a dimension. It is a size or a dimension of the range comparable to the size of the atoms. That's its all meaning of nano. So I just like to clarify possible confusions about a not misunderstood word or a not understood word.
Okay, perfect. Thank you.
I would like to add something to what he just said. Mr. Kesh has explained nano in this case to mean individuality. So it may be that size, the dimension Sander says, which is 1 billionth of a meter. But then in cases of GANs, the emphasis is on individuality. Let's say, for example, of CO2, you have a carbon and 2 oxygens. Now, when they are COO, when they are individual, that should be noted here. That's all I had to add. Thank you very much. This is Gatwa.
Thanks, Gatwa.
So we are talking of entities which are the size of nanometers.
Sure, I understand that. It's 1 billionth of a meter.
Yeah.
But individuality is very important, so that you don't confuse into molecules. People don't see CO2 as a molecule, but here is the C is individual and the oxygens are individual. So individuality is very important in this case.
Yes, thank you very much.
That's my understanding. Thank you.
Thank you, Dr. Reto.
Sure.
All right, so we've learned over the last few workshops. So we have the matter state, we've learned how to create the nano, and now from the nano, where we've nano coated our plates, we can now use all these to start creating our GANS material that we would like. And then from the GANS, we learn about the fields that come off from that GANS, as we've understood that the tiny little GANS that we produce is like the little suns. So it's like a little sun having its own magnetic or gravitational field. Right, so now we'll go on to the creation of CO2 GANs. And the plants all around us are doing this all the time through their leaves. So it's nothing new. It's just something that we've never understood. And now we can also produce our own CO2 GANs. we've got to look at each leaf as a CO2 reactor. So the leaves are creating that CO2 internally. Just like we create the amino acids on the surface of the water, so the leaves create amino acids on the top surface of their leaf. And the shiny layers on all the leaves is your amino acids. So we'll explain that as we go on. So in the fourth workshop, we showed you the different leaf structures, different shapes. And so what this means is that each leaf will be creating a different field strength of that CO2 internally, because the conditions have changed. And we're meaning that the conditions have changed, it's just the different shape of that leaf.
Okay. Jim? Yeah. Okay. I guess one big question that comes to my mind is if you can do a general overview or general look at what is CO2 GANs and zinc GANs, and why would you ever want to make them?
I will be asking, and Dr. Rodrigo will be covering that next week, because it's mainly related to huge benefits on health aspects. Mm-hmm. And next week we'll also be doing how it's useful for agriculture. So we'll be going into the uses of it in the next workshops.
Okay.
Yeah, we just focus on how to make it.
Thank you.
Okay. All right, so what you're going to be needing is your zinc plate, your nano-coated copper plate, a plastic box, a green LED light, copper wire, some distilled water or seawater, and pure sea salt if you're using some distilled water. So I ended off last session about showing this picture about the leaf, whether anybody went outside and noticed that your leaf has sort of that shiny side and underneath has that matte side. So all we're going to be doing is replicating that leaf. Because if we had to view that your nano layered copper plate, now please ensure that when you take your nano plate, as we explained last time, when you make your nano layers, is to please wash your plate very well to remove any of your residue caustic soda that you might have left on that plate. But the nano layer is sort of the same as your shiny side of the leaf, which is also nano layered. And the zinc plate is needed as well. This forms the other side of the leaf structure. So your two plates that you've got are representing the two sides of the leaf. And what this does is it creates a magnetical and gravitational condition around the leaf, which is equal to the mag-grav field strength of CO2 in the environment. So your leaf is creating the condition to attract the fields of CO2 into the leaf structure. So we're going to do the same. So we take your box, and on the one side you've got your zinc plate, and the other side you'd have your nano-layered copper plate. And when you position them opposite each other like that, you're creating the same conditions as the leaf, and you create the same magnetical gravitational condition to start attracting and creating your CO2. Now, in between, when you look at within your leaf, there's different compositions there of water and different amounts and solutions of salt within that leaf, very trace amounts, but they are still there. And so we have to do the same. So within that box, once you've set up your plates, we add the salt water into our container just as like the leaf. So if we're close to the beach, we can use the seawater, or you make your own solution with distilled water, and you could use between 3.5 to 10% of sea salt. I know the ocean water will vary with your salt concentrations of around 4.5 to 5.5%, depending on where you are in the world. And some people have had some success with varying the concentrations of salt in producing their CO2. And to get your solution, for an example here, if you're wanting a 3.5% solution in your water, then you just add 35 grams of your sea salt in 1,000 milliliters of distilled water, and that will give you your 3.5% solution. So once you've placed those, position those plates in your box with your water, please ensure that your plates are also hanging in the water and not resting on the bottom of the container. Now it's important to understand that your nano copper plate that you've created, that this plate creates and controls the condition in your box, because you've created those nano layers, the field from that material crosses this whole area between your two plates and creates that condition within your box. So what we've created is the same as the leaf, and we've got our two plates within the salt water, and this creates the magnetical and gravitational field that is the same as the CO2 to attract. What we need to do next is to connect the two plates with a wire to create a flow. But we have to control the current flow between the two plates. So what one has to do is to connect a LED light, a red or a green light, between the two wires, and so that this LED acts as a resistance or load to the flow of the current, because we need to slow that current flow down. And so we do that with an LED. Okay, so now we just got to look at understanding why we're using these particular metal plates. So when we have a look at the atomic mass of zinc, it's around 65. And the atomic mass of copper is around 63. You look on the periodic tables. But when we nano layer the copper plate, we reduce that to less 5%. So we reduce that to around 59. So when we have a look at the difference between the zinc plate and your nano-layered copper, we have a difference of 6. So what we have done is we've now created a gravitational field strength difference of 6. So when we look at carbon, it has 6 neutrons, 6 protons, and 6 electrons. So we need 50% of the fields, the 6 neutrons, to attract the rest. There's also a portion of graphene or carbon on the layers of your nanocoating, which also gives the plasmatic energy of carbon. So what we're doing is creating and dictating an environment between the two plates of carbon, so that the carbon interacts with the oxygen in the water to create our CO2. So essentially we have the setup the same as the leaf. We have the zinc plate and your nano copper plate, and you have your LED to control and slow that flow between the two. So what you've created is you've created an environment between the two plates, which creates the magnetic gravitational field strength to attract the carbon into that area. And when the carbon comes into contact with the water, it oxidizes to form our CO2. So when we have the LED or that load between the plates, we will be producing around 85% of CO2 and around 15% of zinc oxide. You'll never get a pure CO2 unless we actually seal off the two plates. So we're always going to create a combination here of CO2 and zinc oxide in the water. But this method will definitely give you around 85% of the CO2. So what happens is when you get your box going, is you start creating a field environment around the box, and this grows over time. And because we've now started creating a small amount of CO2 in our box, this also begins to attract CO2 from the environment because it acts as sort of a magnet in the box. So we can also start attracting CO2 to clean up the environment. And we also attract a lot of the carbons, oxygens, hydrogens, and nitrogens, which form the amino acids on the surface of the water. Because what you'll find is after 2 or 3 or a couple of weeks, when you let your setup run, is that you will start seeing a bit of a shiny, oily layer on the surface of your water. And that is essentially the amino acids which collect on the surface of the water. So when we look at the whole environment around our box, you can see that we initially created the condition to attract the carbon. And then as the CO2 is formed in the box, we then also create that condition to attract further CO2, but we're also attracting the carbon, hydrogen, oxygen, nitrogen, which forms the amino acids. So what we're doing is creating a huge environment around our box, which is creating that condition to attract those elements in. And then over time, you'll see that you'll notice a creamy white fluffy powder which forms on the bottom of your container, and that is your CO2 GANs. And there will be many ways to extract this. One of them is to extract the CO2 GANs with a syringe. So you just soak up the bottom GANs from the bottom, and you place that into a separate container. So now once you've extracted all your CO2 from the bottom of your box and put that into a separate container, we now need to start washing that GANs because that would contain quite a bit of still salt in that solution. And so what we'll do is we'll just add distilled water to the GANs and then allow this to settle because it will just puff up your GANs within that water. So we just allow, sometimes it can take 6-12 hours for that to really settle down to the bottom. And then you can just carefully pour off the top of that water so that not to pour away some of your GANs material. And then you just refill that again with distilled water. So you just wash and wash many times to ensure that you've washed all your salt out. What we found is that by placing your GANs into a bigger container, you're able to pour in a lot more amount of distilled water in there to start doing the cleaning process. So this way you're ensuring you get rid of your salt out of the water. And the best way is just to do a taste test to see if you taste any salt that still might be left in your water. If you do, then just continue washing until there is no taste. Collecting your amino acids, say after a few weeks, you'll notice that there's like a shiny, oily layer on the top of your water. That's the amino acids. So the best way to do it is just to take a plastic spoon and scoop this oil off carefully and place it into a separate jar. And this you don't need to wash because it's the amino acids need to be sort of stored in a little bit of a salt solution. So it's just a case of scooping off that oil and placing that into a separate jar. And that